Hi, welcome to my video on even functions. This is a new unit on even and odd functions. Defining an even function. A function such that it is reflected in the y-axis, symmetric to the y-axis, negative x comma y is mapped to x, y, or f of negative x is equal to the f of x. These are different ways of saying we have an even function. Let's do an example of an even function. So the f of x equals x squared, so y equals x squared. So let's take the values of a negative 2, negative 1, 0, 1, 2, as we did in the unit on quadratics. So you take a negative 2 and squared, you get a 4. Take a negative 1 and squared, you get a 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So notice that y equals x squared is a parabola, is a quadratic. So it has a vertex of 0, 0. When x is negative 1, y is 1. When x is negative 2, y is 4. When x is 1, y is 1. X is 1, y is 1. When x is 2, y is 4. X is 2, y is 4. So it's a parabola that's opening upward. And we practice that over and over and over in the unit on quadratics. So just, there's the parabola. It's a U shape moving upward. And notice that this is positive, so x squared is always positive. So this is opening upward from the vertex of 0, 0. So now you can see that it's symmetrical. In other words, this point right here, this point is in the wrong, that's a 2 there, it should be right here. My mistake. And negative 1 is a 1, because I have the table of values of, or the marking grid as of 1, 2, 3, 4. So I thought that was a 1. Normally I would have a 1 here. So there's the point right there. So these two values are, this is 1, this is negative 1, giving you the sine y values. This is 2, negative 2, giving you the sine y value of 4. So it's symmetrical in respect to the y. So let's use, in this unit, I'm going to use this definition of an even function. The f of negative x is equal to the f of x. So negative x and x, negative x and x. So if we take this equation, y equals x squared, then we have y, or let's use the f of x equals x squared. So the f of negative x, so we're putting a negative x in the place of x. So the f of negative x is equal to negative x squared is negative x times negative x, which is x squared. And notice that the f of x is equal to x squared. So x squared is replaced by f of x. So f to the negative x is equal to the f of x. And if that's true, then we have an even function, because it obeys. If f of negative x is equal to f of x, then the function is even. Okay, now let's do some more examples to illustrate that. Show that each is an even function. So we have this one. So we're going to look at, again, we're looking at the f of negative x is equal to the f of x. I had to prove that. So let's put negative x in the place of x. So I'm subbing in negative x in the place of x. So a negative x squared is the same as x squared. So notice that 3 over x squared plus 1 is the same. So that's the f of x. So the f of negative x is equal to the f of x. Therefore, it's an even function. So it's even because the f of negative x is equal to the f of x. Number 2, again, we're going to sub in f of negative x. So we're putting in negative x in the place of x. Wherever I see an x in the equation, so I'm putting negative x in the place of x, negative x in the place of x. So negative x to the fourth power is an even power of a negative numbers, of a negative term. So that's x to the fourth. And negative x squared is x squared minus 6. So notice this is x to the fourth, x squared minus 6, the same. So that's the f of x. Therefore, it's even. And why is it even? Because the f of negative x is equal to the f of x. And we do that again here. So we're putting a negative x in the place of x. So putting negative x in the place of x. And again, negative x squared, negative x all squared is x squared minus 9. And again, this is the same here as here. So that's the f of x. Again, this is even, and I just write it. Why is it even? It's even because, and I just make this statement, because the f of negative x is equal to the f of x. That's why it's an even function. Now we have an absolute value. And just to illustrate, we did a unit on absolute value. And the absolute value is defined as, the absolute value is x when x is greater than or equal to 0. And the absolute value of x is a negative x when x is less than 0. So that means that the absolute value of x, if you take a 0, absolute value of 0 is 0. If you take a 1, absolute value of 1 is 1. And we put 2 in, absolute value of 2 is 2. And we put a negative 1 in, the absolute value of negative 1. Negative 1 fits here, so the negative of a negative 1 is 1. Let's put a negative 2 in. And negative 2 fits here, so the negative of a negative 2 is a positive 2. So we get a V shape. So there's the absolute value function. And again, note that is symmetrical in terms of y. But if we take the f of negative x is equal to the absolute value of negative x. So the absolute value of negative x is the same as the absolute value of x. There's no difference. So no matter what number you put in here, you put in 2, you put x is 2, you get a negative 2, which becomes 2 absolute value. You put a negative 2 in here, negative of a negative 2 is 2, whose absolute value is 2. So that's f of x. So it's even. And again, why is it even? Because the f of negative x is equal to the f of x. Okay, let's continue. Just a question with a different variation. Which one or ones is an even function? Or which ones are an even function? So there could be even or not. So again, let's plug in the f of negative x into this equation. F of negative x to the fourth power, negative x squared minus 1. So that becomes negative x to the fourth power. Power is even, so that becomes x to the fourth. Negative x squared is x squared. And again, x to the fourth, x squared minus 1, same as here. So that's the f of x. So this is even. Why? Because the f of negative x is equal to the f of x. Let's look at b. F to the negative x, the f of negative x. So we get negative x to the sixth. And we get negative x cubed. So we're putting negative x in the place of x. Negative x to the even power, all to the even power is just x to the sixth, and 4. And a negative x to an odd power is negative of x cubed. So the power is still 3, but it's negative. So that gives us x to the sixth, subtract 4x cubed. So notice this is x to the sixth, but this is positive and this is negative. So it's not even, because the f of negative x is not equal to the f of x. So it's not even. And let's look at this one. We have x squared, so f to the negative x, at the f of negative x, sorry. The f of negative x is negative x goes in the place of x. absolute value of negative x. So we got a negative x in. Negative x all squared is x squared. The absolute value of negative x is the same as the absolute value of x. And that's the same as that. So that's the f of x. So this is even. Why is it even? Because the f of negative x is equal to the f of x. So that's the review of going over why some functions are even. And hopefully you understand what you have to do. And if you do, if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content of my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.